Today we will start with another type of motion which is performed by Earth around the Sun is a revolution. So we'll talk about the revolution of Earth around the Sun. We all know that the time period of revolution is 365 days, in fact 365 and 1/4 days. As we know that the Earth's rotational axis is tilted by an angle of 23.5 degree with respect to the vertical axis. So it is the rotational axis of Earth. Now, this tilt of rotational axis plays an important role and causes the different seasons on Earth. Let's come here. These are Sun, and this is the annual orbit or the orbit of revolution of our Earth around the Sun. I want to mention here that I will say that this is the position A, this is the position B, and this is the position C, and this is the position D, and I will refer them with the alphabets A, B, C, D. Now, as we have talked about the rotational axis of Earth, so as we know that the rotational axis is a bit tilted, so we can visualize it like this. Now, when we talk about the Earth, we have an imaginary circle which is called equator, and above that the hemisphere we call it northern hemisphere, and below that we call it southern hemisphere. Now see, on the positions A and B, you can clearly see that this tilt causes an extra inclination of Earth towards the Sun. But when you consider the point A or the location A, we can see that this inclination is of north pole towards the Sun. That causes a non-uniform distribution of Sun's energy on Earth. See that in this location, the Sun's rays are more straight, perpendicular and short in northern hemisphere, while it reaches with difficulty towards the south pole of the southern hemisphere. and in whole southern hemisphere it is very much tilted and elongated. That's why what we see that in this condition, the most of the rays from the sun which comes hit northern hemisphere in the straight way. That's why in this condition, northern hemisphere is getting more heat and light from the sun, and in northern hemisphere at this position, the sun is at the optimum angle, the most straight angle. The sun's rays are particularly short and very much more heat content is in the northern hemisphere as compared to southern hemisphere. So we see that at this location there is the summer in northern hemisphere and winter in southern hemisphere. Now we'll discuss about the location B, and what we'll see here that as this tilt remains the constant in the whole path, so the light rays from the sun reaches the elongated way to the North Pole, while it hits straight, short and more perpendicular in the southern region. So what we see that the heat and light content is gained more by the southern hemisphere, and that's why here the summer is in the southern hemisphere and northern hemisphere has winters. Now, in northern hemisphere as India lies, and in southern hemisphere we can say Australia lies, and we will see that when the northern hemisphere has the summer, the southern hemisphere will have the winters. While in northern hemisphere, when the winter will be there, the southern hemisphere will have the summer. Now what we see that this is the position of 21st June, and it is the most hot day in the northern hemisphere, while this is the day of 22nd December, and this is the most cold day or the coldest day of winter in northern hemisphere, while it is the hottest day of summer in southern hemisphere. Now, what happens in the conditions C and D? You can see that the tilt in this case is parallel to the sun. So there is no case of more inclination of earth towards or away from the sun. Now what we see that in these two conditions C and D, the part of earth receives both northern hemisphere and the southern hemisphere, both parts receives the same energies, and this is the condition of 21st March, and this is the day of 23 September. As we know that the revolution and this tilt causes the elongation of day and shortening of nights, and then consequently elongation of nights and shortness of the day. So what we see when this 21st June comes, the day is most elongated in northern hemisphere, while night is most elongated in southern hemisphere, and here we see that the shortest day occurs in the northern hemisphere, while the night is the most elongated. Now 21st March and 23 September is the day when the duration of day and night are same. So what we call these days? These days are called equinoxes. This 21st March and 23rd September is equinoxes, After winter, there is spring in northern hemisphere, while there is autumn in southern hemisphere. When we are talking about these equinoxes and the solstices, we are talking about the northern hemisphere, so we'll call this equinox, 21st March, as the spring equinox, and this equinox we'll call that autumn equinox. Here northern hemisphere will have the autumn season and southern hemisphere will have the spring season. The most elongated day or most elongated night, that day which has the most elongated day or the most elongated night are called solstices. And this solstice is the summer solstice, and this solstice here is the winter solstice. So this is the reason of formation of seasons, and just because of it we get 4 seasons on earth: summer, winter, spring and autumn. One more thing I want to tell you here, the two terms perihelion and aphelion. As we know that the planets revolve around the earth in elliptical orbit, so there are the 2 points at a point on which the planet is closest to the sun. So it is the point of orbit which is closest to the sun, while it is the point of orbit at which the planet is farthest from the sun. But for Earth, perihelion and aphelion has a very less amount of difference. 147 million kilometer is Earth's perihelion, while 153 million kilometer is Earth's aphelion. So we say at the aphelion the Earth is farthest from the sun, and at perihelion the Earth is closest to the sun. But that is important fact that in northern hemisphere when there is winter, Earth is closest to the sun, while in summer Earth is farthest to the sun. While in southern hemisphere we can take it just opposite way. In summer there is the Earth closest to the sun, and in winter it's farther from the sun.